Hello, once again, we're going to be taking a look at some various videos covering different topics from ALEKS. As it is Wednesday today when I'm recording, these are topics that are from the previous week that people did not complete on time or that were especially difficult and caused people need to go back over them. The number of topics I do for Wednesdays is going to kind of depend upon how much you guys complete each week. So some of these will be a bit larger or a little bit smaller depending upon what is left from the week behind. It is worth mentioning that these particular topics can be accessed if you complete a given week early, which is why I do them a little bit later in the week. If you have some time on Monday, Tuesday, and Wednesday to knock out a week early, then on Thursday and Friday you can always go back to other weeks, or if you prefer, you can even work ahead a little bit. So just kind of keep that in mind. Even though you might not currently have access to these topics, if you finish a week early, you can go back and still get credit for them. As long as you learn the topics at some point in the semester, you always get credit, even if they're lost on knowledge checks or you didn't get them done in time for the first due date. Now, with that out of the way, we do have three different topics that we are taking a look at today. We're looking at solving for a variable in terms of other variables using addition or subtraction with division. We also have solving for a variable inside parentheses in terms of other variables. And then finally, we are looking at solving equations with 0, 1, or infinitely many solutions. I changed up the recording format a little bit compared with what I did yesterday, just to make flow a little bit easier for me on the editing side, so I don't have as much to do, and hopefully cut down on how much I have to Alt-Tab. So rather than having to tab between windows, I'm just going to switch between tabs on this same window here. I have a number of topics again with one question for each. I'm just going to go ahead and pop through them here so we can take a look. Our first one, we're looking at solving for a variable in terms of other variables using addition or subtraction with division. The task here is we need to solve for b in the equation 5b plus 11c equals a. Solve in this particular instance isn't trying to have us find a specific value for b. Since we have two other unknowns, c and a, there's no way to find a unique solution to this particular equation. Instead, what it means in this context is that we need to isolate b by itself on one side of this equation to finish this problem. You can kind of see that they've started it for us here in the box where they have b equals, and we need to complete that expression on the right hand side to have a correct value for b, or rather, again, I should say a correct expression for b. So I'm going to go ahead and pop over to the whiteboard here. Again, for this one, we had 5b plus 11c equals a. As we're trying to isolate b, the basic premise here is that we're going to use inverse operations to slowly peel off anything that is attached to b at its side of the equation. In this particular case, we always start from the outermost and work our way in closer and closer to b as we go, which means that the first thing we actually need to get rid of is this plus 11c. It's still on this left-hand side, which is not where I want it, but it's the furthest thing away from b. So the inverse operation that I'm going to use in this case, if this is plus 11c, to move it to the other side of the equation, I'm going to subtract 11c. Now this c is not going to combine with the a that is already on the right-hand side, which is why you can see me kind of writing them staggered on this right side. But on the left, by design, plus 11c minus 11c, these two are going to create 0. They're going to cancel with one another, essentially. Meaning that what's left on the left-hand side is 5b now, and the right is a minus 11c. The last piece to peel off of the the letter b here is this 5 that's being multiplied to it as a coefficient. And kind of similar to what we saw here when we had addition, its inverse was subtraction. This 5 is being multiplied with b, so its inverse is division. We're always doing the opposite when we move from one side of the equation to the other. A key thing to note here is that when you divide the right-hand side by 5, you're dividing all of the parts, both a and minus 11c. So I like to write it as a single rational expression here, a minus 11c all over 5. If you watched the videos yesterday, you might know that sometimes ALEKS likes to separate these out, so I'll show you how that looks as well. But the important part here is that on the left-hand side, multiplying by 5 and then dividing by 5, those are inverse operations. They create 1 and essentially cancel here. So we're left with b equals a minus 11c all over 5. Or again, if you wanted to write it out as two separated terms here rather than with a single denominator, you could write this as a over 5. Get that 5 looking correct. Minus 11c over 5. You might even sometimes see it as 11 over 5 times c. That would also be another way to represent this. Let's go ahead and take a look here if we ask it to solve for us. Okay, so a little bit different than before. They actually did leave this as a single rational expression. Whether you write it like this or in one of the other formats that I showed here, though, it will be counted correct in an exam situation. That is the first topic. Let's go ahead and erase here and get ready for our second one. The second one is kind of a similar flavor. We're just going to be kind of changing the type of initial equation we deal with, but we're still going to be looking at solving it for a particular variable using some techniques. What's going to be different on this one is the inclusion of parentheses to make our work a little bit more difficult. Here is our new equation. We have y equals 4 times in parentheses x minus a, and we want to solve this for x. Now, this one, there are actually a couple different approaches to how you could do this. I'm going to show you what I think is probably the easier approach out of the two. So I'm going to go ahead and pop over here. We have y equals 4 times in parentheses x minus a. Again, ultimately, we are trying to get x all by itself on one side of the equation. One thing to note here is, again, there's different ways you could move forward. Some of you might look at this and think that the proper way forward is to go ahead and take this 4 that's being multiplied with x and minus a here in parentheses and basically distribute that across. Do 4 times x and 4 times negative a. And that is not incorrect. That is one option for how you can proceed. However, in this case, I do think there's a slightly easier approach instead. What I'm going to suggest for this is actually, just like we did on the previous problem, since our ultimate goal is to get x by itself, we're going to peel off anything that's attached to x or on the same side of the equation as x, starting from the outside and working in. So rather than trying to multiply the 4 across, since it's the furthest thing out from x due to the parentheses, we're actually just going to peel it off first. In this case, this is 4 times x minus a, so its inverse operation would be to take this right-hand side and divide everything by 4. Whatever we do on the right, we also have to do on the left to maintain balance in our equation. And here, multiplying by 4 and dividing by 4, again, will create 1. They essentially cancel each other out. And so now we have y divided by 4 on the left side and x minus a on the right side. Now, if you've gone the other route and distributed the 4 to the x and the negative a, that's not wrong. If you go through the steps from there, you'll still get the same correct final answer, but it'll be formatted a little bit differently. And it's not really work we have to do. We're really just adding on how much we have to do if we distribute that multiplication first, instead of just immediately dividing both sides by 4. And you can see here that actually, because of the way we set it up, we only have one step left. To finish isolating x, we need to get rid of this minus a. So we need to add a to both sides, because that's the inverse of subtracting a. We're going to add it on the left as well to maintain balance. Again, I'm going to stagger it since it's not going to combine with the y over 4 that's already over here. So now that x is all by itself on one side, on the other side, we have y over 4 plus a. You could have also written this as a plus y over 4. It really doesn't make any difference. And even though we have our x on the right-hand side, this is still one way to write our answer. X equals y over 4 plus a. Again, there are different formats for how you could get the answer here. If you went with the different approach where you actually distributed 4 across first, yours would look a little bit different. The answer that you would get instead would be y plus 4a all divided by 4 if you went that route. And we can see that these two things end up actually being the same, because if we did y divided by 4, we get y over 4. And if we do 4a divided by 4, that gives us just a. Both of these, again, are considered correct, but in terms of the least amount of work required, I generally prefer to go with the route that I showed you here at first. Rather than distributing across, just get rid of the multiplication by 4, since that's what we're going to do eventually anyway. Let's go ahead and pop back over to the topic tab itself, see how ALEKS formats it. And you can see here that they do it as two separate terms, y over 4 plus a, kind of mirroring that same first approach that I showed to you all as well. That leaves us with just one topic left to take a look at here. Here we're actually going to be dealing with two separate equations, though. We are looking at solving equations with 0, 1, or infinitely many solutions. So for these two equations here, we have some possibilities. These are both multiple choice and kind of also short answer. If you kind of decide that there is a solution, we need to write that in as well. Hopefully here we'll have some examples, though, of what no solution and all real number solutions look like as well. Let's just go ahead and clear a little bit of space on the whiteboard first, and then we'll take one of our equations over. These ones end up being a little bit more complicated because they're trying to obscure, so you can't just look at the equations and automatically determine if they are no solutions or all real numbers. They're trying to make it so you can't take a really quick shortcut, which I understand, but it's going to make these equations a little bit longer to write. So our first one here, we have 3 times in parentheses 2 plus v minus v. Start with that. 3 times 2 plus v minus v. Let me make sure that I got that correct. Yep. On the right side of our equation, we have 4 plus 2 times in parentheses v plus 1. 4 plus 2 times v plus 1 in parentheses. All right, what we're going to do to try and solve this equation is kind of similar to the work that we did on the first 2 topics. We want to isolate our variable. In this case, that is v. But we have multiple v's on both the left and right hand sides of these equations. So before we can go through the process of isolation, let's figure out what we actually have. And part of the work we're going to have to do is perform some distributions to clear out parentheses. So it's a lot easier to see what I do and don't have. I'm going to distribute the multiplication by 3 here on the left, and this multiplication by 2 on the right. 3 times 2 will give me 6, and then 3 times v will give me 3v. Don't forget the minus v that was already on the left-hand side. On the right, we have 4 plus, and then 2 times v will give me 2v. 2 times 1 will give me 2. Let's go ahead and take what we have here and simplify the left and right-hand sides. We only have one constant on the left, so 6 can just chill out. 3v minus v, however, is going to give us 2v. So the left-hand side of this is 2v plus 6. As for the right-hand side, this time we have just one v term, but 2 constants. So the v term is just going to chill, 2v, and then we have our 2 constants going to combine. Positive 4, positive 2 is going to give us plus 6. Now at this point, we actually have enough information to determine the answer to this question. You'll notice that the expression on the left and right-hand side of this equation match with each other perfectly. When this happens, this is again a situation where we're trying to solve for v. We're trying to ask ourselves what things we could use for v that would make this true. Well, the thing is, 2v plus 6 is always going to equal 2v plus 6 no matter what number you choose for v. And because of that, this is a situation where our answer is all real numbers. It doesn't matter what thing you could possibly substitute in for v here in this equation, you're always going to get the same thing on the left and right. If you replace v on this side with 1 and v on this side with 1, they're always going to match with each other. Regardless of what you put here, it's always going to work. So as soon as you see this, where you have 2 of the exact same expression on opposite sides of an equation, our conclusion is all real numbers. I'm going to leave that one there, but let's go ahead and grab our second equation. All right, this one's kind of similar. On the left-hand side, we have 2 times u plus 2 in parentheses minus u. So 2 times u plus 2 in parentheses minus u. That'll give us our left-hand side. How about the right? We have 3 times u minus 1 in parentheses plus 9. Okay. 3 times u minus 1 in parentheses plus 9. Similar to the previous equation, same thing as before, we ultimately want to try and solve by isolating u by itself. So what we're going to have to start with is seeing what we do and don't have, and that's going to again involve these distributions. We're going to distribute this 2 to both u and 2 here in parentheses, and this 3 is going to get distributed to u and negative 1 here. Let's see what we get. 2u plus 4 on the left side. Don't forget the minus u that was already there. And on the right, this is going to become 3u minus 3 plus 9. And we're going to go ahead and continue forward from here. I'm going to check something briefly. Yep, all right, didn't make any mistakes on the copying. From here, let's go ahead and combine like terms on the left and right. 2u minus u, that's going to give me just a single u, plus 4. On the right-hand side, 3u, that's just going to be by itself. And then we have minus 3 plus 9, that's going to give us plus 6. After that distribution, we do not have the same expression on both sides, and we don't have similar expressions really at all here. So in this particular case, this is just going to be a normal equation, one where we're just going to solve by slowly isolating u. One thing that we're going to do is we're going to choose to move u terms to one side of the equation and our constants to the other. It doesn't really matter which side you do it on, so just for my own sake, I'm going to go ahead and move all of the u's to the left side of the equation and move all of the constants to the right. And again, we're going to use inverse operations to do so. To get this 3u on the right over to the left, I have to subtract 3u from both sides. Again, this is positive 3u, so inverse of that would be negative 3u. And to move this constant of plus 4 from the left, where I don't want it, to the right-hand side where I do want it, again, I'm going to perform the inverse operation. Instead of plus 4, I'm going to subtract 4 from both sides. Positive 4 and negative 4, positive 3u and negative 3u, by design, are going to cancel out with one another. And as we take it over here and look at our new sides, we have u minus 3u on the left and 6 minus 4 on the right. This will give us negative 2u equals 2. And the last piece of the puzzle is to divide both sides of this equation by negative 2. We're technically multiplying by negative 2, so its inverse is to divide by negative 2. That'll leave us the left-hand side as just u, finally all by itself. And then 2 divided by negative 2 will give us negative 1. So in this second equation, our answer here is that we actually had just a single real number solution for u, a single value we could substitute in and make the left and right-hand sides of this original equation match with each other. That value being u equals negative 1. So in the case of the first equation, we could have chosen anything for v back at the start, and it would have all come out in the wash as long as we replaced each v with the same value. Down here, we need a specific u value in order to make this one true. Now, we didn't have a question here that went through the process of no solutions, so let me talk about that here briefly. The no solutions route is actually really similar to the all real numbers solutions. When you see this particular setup after we've gone ahead and multiplied to clear parentheses and combine like terms, when we had matching expressions on the left and right hand side, this was all real numbers. However, if our expressions had not matched perfectly but been similar, let me show you what I mean. If we'd had something like 2v plus 3 equals 2v plus 6, in this case, where we see the same coefficient on v but two different constants, 3 and 6 here, this is going to be the case where we have no real solutions. If they're a perfect one-to-one match, it's all real numbers. If your coefficients match, but your constants don't match, then it's no solutions instead. If you look at the one that we just did here, u plus 4 equals 3u plus 6, we didn't really need to worry about it. Our coefficients were 1 and 3, so we didn't really have to worry about the all real numbers or no solutions options. You only have to watch for those two if after the simplification, you have the same coefficients on your variable terms on opposite sides. All right, that's going to do it for these particular topics for today. This is all for the videos I'm going to be recording for this week. Next week, we're going to repeat the process with Monday, me covering stuff from the week ahead, and Wednesday, I'll be going over anything that was still kind of a lingering issue from week 2. So make sure to check back in on those. Also, keep an eye on your email going forward for the rest of the week, because again, I will be sending out reminders on Friday for anyone that needs to catch up on work. That is going to be it for today. I will see you guys later.